Hey everybody, Ali Basha here and welcome to the channel. Today we're diving deep into the world of routing. It's like the postal service of the internet. But instead of letters, we're talking about packets of data. Now you might be thinking, routing sounds boring. But trust me, it's way more exciting than it sounds. It's the magic that makes sure your cat videos get from YouTube servers all the way to your screen. Today we'll explore the different types of routing and their significance in network communication. We'll break down the complexities, look at some real-world examples, and by the end you'll be able to explain this stuff to your grandma. Well, maybe not your grandma. First up, let's talk about static routing. Imagine having to manually address and send every single piece of mail that leaves your house. That's kind of what static routing is like. With static routing, network administrators have to manually configure each and every route for their network devices. It's like having a map where you've drawn every single road and intersection by hand. Now, this might sound tedious, and frankly it can be, but there are some situations where static routing makes a lot of sense. For smaller, simpler networks with very predictable traffic patterns, static routing can be a really reliable and secure option. It's also a great choice for networks that need super tight security since you have complete control over where traffic is going. Think of it like this: if you're sending a super important package, you might choose to deliver it yourself instead of trusting it to a courier. You know the route, you know the destination, and you're not taking any chances. However, as networks grow larger and more complex, managing all those static routes can become a real nightmare. It's like trying to update that hand-drawn map every time a new road gets built. That's where our next type of routing comes in: default routing. Imagine you're sending a postcard. You don't need to know the exact route it'll take to reach its destination, right? You just need to get it to the post office and they'll handle the rest. That's the basic idea behind default routing. In default routing, we're basically telling our router, hey, if you don't know where this packet needs to go, just send it this way. This way is our default gateway, which is typically another router or a firewall that has a more complete understanding of the network. Default routing is super common in smaller networks, especially home and small office setups. Your home router probably uses default routing to send all your internet traffic to your internet service provider, ISP. It's simple, it's effective, and for most basic internet usage, it gets the job done. But just like relying solely on the postal service can sometimes be slow or unreliable, default routing has its limitations. If that default gateway gets congested or goes down, your entire network can grind to a halt. Plus, in larger, more complex networks, relying solely on default routing can lead to inefficient routing paths and slower performance. Chapter 3. Let's move on to the big leagues: dynamic routing. This is where things get really smart. Imagine a GPS navigation system that constantly monitors traffic conditions and automatically adjusts your route to get you to your destination as quickly as possible. That's the basic idea behind dynamic routing. Dynamic routing protocols like OSPF and BGP are used by routers to talk to each other, share information about the network, and automatically update their routing tables in real time. They're constantly learning and adapting to changes in the network like congestion, outages, or even new connections. This makes dynamic routing ideal for large, complex networks where manual configuration would be impossible. It's like having a team of expert traffic controllers constantly optimizing the flow of data across your network. But with great power comes great responsibility, and dynamic routing does come with some challenges. For one, it requires a deeper understanding of networking concepts and protocols to configure and manage effectively. It can also be more resource-intensive than static or default routing, as routers need to constantly communicate and process routing updates. But for most modern networks, the benefits of dynamic routing far outweigh the challenges. Thanks for joining us on this journey through the different types of routing. We've covered the basics of static, default, and dynamic routing, and you should now have a better understanding of how data travels across networks. Remember, choosing the right routing method depends on your specific network needs and complexity. Static routing is great for small, secure networks, default routing is perfect for simple setups, and dynamic routing is the way to go for large, complex environments. Don't forget to like, subscribe, and hit the bell icon for more insightful tech content. And be sure to let me know in the comments which type of routing you use or plan on using in your network. See you in the next one.